Yeah, I put this engine together. This is a 582 cubic inch big block Chevrolet, dark block, big M. One of the modifications I did, I left everything the same cam, same everything, except I put mechanical fuel injection on the engine, and it kind of like stepped up the whole program as far as horsepower and speed of the car. Here's the fuel injection over here. We originally had a 1150 Dominator carburetor on it, and I guess I couldn't leave well enough alone. I had to try to squeeze more horsepower out of it. So we got this Terminator fuel injection. This Terminator is, you look inside, there's no boosters. No boosters. They're 2.5-inch throttle plates, and it's 2100 CFM. It's a tremendous amount of CFM goes through this thing. It's almost like running two Dominators. So to do the modification, you have to put the manifold, we used the same manifold. They put these bosses on the manifold, and they're there for a reason, so that you can drill and tap it for fuel injection. So we stick it in a Bridgeport, nail it down, clamp it down on the table, make sure everything's straight. We drill and tap it with a 1/827 pipe thread. And then when these nozzles, these are the nozzles that go inside. You can look inside, you'll see the nozzles spray directly into the port, onto the valves, directly onto the valves. And every cylinder is getting the same distribution of fuel. So it stepped up the program. And then in stepping up the program, we took the car to test. I tested the car. The car picked up 5 miles an hour, which is really a big move as far as miles per hour go. But now we're starting to hurt some parts. And my reason for the video is to tell you that, the lifters, you have to really keep a close watch on roller lifters, needle bearing lifters. I made the 2 passes, was real happy, very consistent passes, 2 of them, 170 miles an hour on a throttle stop, and took the car the next week, thinking I'm all prepared for the race, went to the Dutch Classic, made 1 pass down the track, and broke a roller lifter. This is what it looks like. This went into the pan, broke the lifter. And like I said, the reason for the video is don't do what I did. I pushed these maybe a little bit too many runs on these lifters, and then had metal fatigue or whatever happened, broke the lifter, winds up wiping out the cam. You can look at the cam here, it wiped out the lobe on the cam. Then you got all that junk goes through the engine. So the only thing you can do is go home, take the engine completely apart again, and you got to start over again. So when I did that, I wound up finding another problem. Maybe it was good that I did, but I found that my wrist pins, I was getting some marks in my wrist pins, that maybe my wrist pins were flexing. So we wound up had to put a different type of different type of wrist pin in the engine. And these wrist pins are made by the Trend Company. These are made of H13, and they have 20 thousandths more wall. These are the old ones we took out. These had 160 thousandths wall, and we put in the H13, the tool steel type wrist pins, at 180 thousandths wall thickness, to hope that it solves the problem. And this way here, we had to go 2 thousandths heavier on the wrist pin so that we could save the pistons. So these were 2 thousandths larger for the honing, to hone them 2 thousandths so that we could save the pistons, and we had to rebush all the connecting rods. This is the connecting rods we use. They're made Lenati company. I already assembled them. You know, to show you the assembly, there's a little spiral lock rings that go inside these things. They're a real pain in the neck to put in, and it's very time consuming putting those double locks in there. But this is the piston that we ran, 14.5 to 1 Wiseco, gas ported, and the ring package we were running was 043 top ring, 043 second ring, and 90 millimeter or a 3 millimeter oil ring. And this is the setup that we ran. They have a little coating on them. We wore a little bit of the coating off of this, but we were making a lot of horsepower. So anyway, just showing you, you know, that the pushing some of the parts sometimes. You know, you got to really watch. You know, you got to really count the number of runs that you put on your metallic part, especially with needle bearing roller lifters. They make other kind of roller lifters that are bushing type. You know, I didn't go that way. I replaced mine. I'm going to replace mine with the special Crowler. These are severe duty Crowler lifters, and we're going to put these in here. These have you won't be able to see it, but there's some kind of an internal oiling, a high pressure oiling that goes in and lubricates the needle bearings. So like I said, you got to really count and count how many runs you put on your lifters, because this can be a weak link and cause you a lot of problems down the road when, you know, when stuff like this fails. And it could have been a lot worse, you know, the damage that it done. So just showing you, you know, what we did here with this new lifter. We're going to try this Crowler lifter, and like I said, it's got the high pressure oiling in it. And I didn't want to go with the bushings. I felt that maybe the bushing would skid over the top of the cam if it didn't turn. Just my preference. I'm kind of like anti-friction bearings. The stuff that I think about. Anyway, another thing that we did with the block, I had this block, a lime board, and this is a little upgrade. You can see this is not normal here. This was done by Charlie Weston Machining. He's one of the real good cast iron block guy for a line honing, and you can see this little groove that was put in here. And then what you have to do on the upper bearing, you have to drill a hole, and that allows for more oil to go through the main bearings. You could also see I had a little bit of wear. I had 2.5 thousandths clearance. I'm putting the engine back together. We're going to go 1/1000th bigger on the clearances, on the oil clearances, and go 3.5 thousandths on the mains. And these are calico coated bearings. Is what I would recommend. I like it, but the only thing is, like I said, I saw this little bit of wear in the bearing, so we're going to go 1/1000ths bigger, you know, on the bore. And replacing the camshaft, wind up, got to put a new camshaft in it. So I guess I could have bought the same camshaft and put it in, because I was happy the way it ran, but I figured let me make a change, and I took and I changed it. You know, I went with 24 thousandths more intake lift, and I actually added 6 more degrees of exhaust duration in this camshaft. So we're going to try this, and hopefully maybe it'll go faster, I hope. But anyway, it was a little tweak that I'm going to do and see what it does, but you know, see if it does things for the better. And doing that, I have to change my valve spring combination. We were running 2-inch installed height being as I'm going with a bigger lift on the intake, I have to go to 2.100 on my installed height, so I have to change all the intake springs. And we have to have, we're going to wind up with 337 pounds of seat pressure at 2.1 and 900 pounds of open pressure when the camshaft opens. So this is what's recommended for this cam. So we got to replace 8 valve springs. I use only PAC. The PAC valve springs are the springs I use. I use the 1247s on the exhaust valves, and I'm using 1248s on the intake valves. So we have to change the installed height on the valve springs. Also, when you have all that metal going through there, you got to knock all the cam bearings out. You got to knock all the plugs out. The block has to be thoroughly cleaned again and washed. And I also use coated cam bearings. So the cam bearings have a coating on them also. And I think this is the way to go. Anyway, this is just the first video. I will show the assembly of the engine as we go along. And I'll show you how we're going to put it together. A lot of my friends asked me to show some of this stuff and how I go about it. And another upgrade that I did was I went to a different type of a crankshaft. This crankshaft weighs 10 pounds more than one of the other crankshafts that I had used. This is a Manley crankshaft, and the difference in the crankshaft, it has counterweights on the center throws. And I think it was recommended that we do that because it's easier to balance the engine, and makes it a much stronger crank, but it is much, it's 10 pounds heavier. So that's the way we went with that. So anyway, like I said, we'll keep you upgraded on the assembly of the engine. This is a new valve cover that I bought from Biondo Products. It's got a 3/8 rail on it, and hopefully it seals better than the valve covers that I had. The workmanship is incredible on these valve covers, and the seal, we should get a real good seal for the vacuum in the block. Anyway, we'll talk to you next time. Thanks for watching.